All right, let's look at the homework 7.9, problem number 6. All right, so we have a population density function is given, and we want to find the population over a rectangular region. All right, so let's do that. All right, so it's going to be a double integral. So population, say, let's call it P, is equal to, all right, so it's going to be a double integral. And then, so population density function is 400, actually 4,000, x times e to the y over 1 plus 2x squared. Right? We can do it with respect to x or with respect to y. It really doesn't matter. I'll probably just do it with respect to x and then with respect to y. Right? For the fixed y, and you can see that, so let's say fixed y here. X is always start from x equals 0 to x equals 4. So we know that it's going to be, x is going to go from 0 to 4. Right? And then to cover the entire region, y is going to start from y equals -2, which covers that part, and all the way to y equals 0, which covers that, right? So it's a -2, so y goes from -2 to 0, so -2 to 0, right? But you can see that x and y can be completely separated in this case. So I'm going to, let's see, I'm going to do this, right? So 4,000 is a number, but I'm going to pull out the 1,000. All right. Then here, since this is an integral, let's see, e to the y has nothing to do with x, so we can just pull e to the y. Actually, I'm going to put e to the y over here. So you have e to the y, right, outside, and dy, right? And the rest of it is going to be, let's see, 1,000 is pulled out. You still have 4, and you still have x, and then we still have 1 plus 2x squared. And this is with respect to x, so it's going from 0 to 4, and this one goes from 2 to 0, right? But you can see that here, this has nothing to do with x. We can just completely separate x and y this way, right? Then we can just evaluate this. The reason why I did this is that, let's see, 1,000 is just a constant multiple. And here we have a convenient form of structure here. The denominator, say, let's call it g of x. Then you can see that this is exact derivative of g of x, right? So we can do antiderivative of that is natural log of, and we don't really need absolute value because that quantity is never negative. So we have that, and then going from 0 to 4, right? And antiderivative e to the y is easy because it doesn't change. So e to the y is going from -2 to 0, right? So then you're going to have, let's see, we just have to clean it up, right? So you have 1,000 in front, right? Plug in 4 here. So 4 squared will be 16. And 16 times 2 is 32, plus 1, 33. So you have a natural log of 33, right? And then multiply by, right? Plug in 0, it's 1, minus plug in -2, so e to the -2, right? Right, let's find this number. Let's see, we want to round the answer to nearest integer. So we want to, so this is approximately. All right, so I'm opening up GeoGebra here. So it's a 1,000 times natural log of 33 times 1 minus exp e to the -2, right? Hit enter. So it came out to be 3023. So 3023, right? So let's type it in. All right, so we got 3023. So let's check the answer. All right, then let's see, we got the population correctly, right? So next question is the average population density of the, let's see, of the town more than 500 people, right? So we are dividing, so 3023 by, so this is a 2 by 4, so it's divided by 8, which is not certainly bigger than 500. So answer would be no. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.